Hello, my name is Evan Santos. Today, I will be talking about genetic algorithms, concepts, and applications, specifically the text by K.F. Mann, K.S. Tang, and S. Kwong. The presentation I am doing today will be broken up into 4 parts. From slides 3 to 4, we're going to focus on what is genetic algorithm. From 4 to 11, we're going to talk about the genetic cycle specifically. From 12 to 13, we'll be talking about the applications, and for the last slide, 14, we're going to wrap it up by ending with the conclusion. The most important question you have to know to understand this presentation is what is genetic algorithms? Genetic algorithms are a computational optimization method inspired by biological evolution, specifically things like DNA. This resembles the process of natural selection, most commonly known made by Charles Darwin, to discover the best solutions to various and difficult problems that deals with search and optimization. To continue more on what genetic algorithms are, I also want to start talking about the genetic cycle. So as we see right in front of us, we have an example of what kind of the genetic cycle looks like. So I just want to state that throughout the presentation, we're going to break down each individual part of the genetic cycle. But for now, as I said, we have an example in front of us. So just to break it down shortly, we have the initial population at the top, which randomly creates the so-called initial population. And next up, we have the calculating the fitness value, or aka the evaluation, which computes the fittest of each individual of the population given. Next up, we have selection. And this is the process of choosing the individual deemed the fittest, and we call those the parents. Again, we'll get more into that later on. Crossover, which is combining the materials from each of the parents. And then mutation, we have basically it just changes each of the genes given from the parents. Now, this part of the presentation, I will go more in depth about each element of the genetic cycle. So as we start off, this is the initial population, which in genetic algorithms, it deals with a population with random solutions. These tend to be called chromosomes, like the DNA strands. Chromosomes, more specifically, are they represent each possible solution encoded as a string of various binary symbols, 0 and 1. If it helps, you can think of 0 as like the X chromosome and 1 as the Y chromosome. After the initial population in the genetic cycle, we now have the fitness function, or the evaluation, or calculating the fittest value. So basically, it computes the fittest of each chromosome from the initial population given. The strongest chromosome, or the stronger the chromosome is, the more likely it is to be selected for reproduction. So basically, just think of it as finding the strongest out of the bunch. As said in the text that was given for this assignment, it says, throughout a genetic evolution, a fitter chromosome has the tendency to yield good quality offspring, which means a better solution to the problem. This will make more sense as we keep going. So after evaluation, or the fitness function, or calculating the fittest value, we have selection next up, which is the determination of which chromosome deserves to be reproduced. The various selection techniques that was presented in the text was, for one, the routine wheel parent selection, which basically gives fitter chromosomes a higher probability to get picked, while still giving the lesser fit chromosomes a chance. So a way you could think about this is basically when you think of a roulette wheel and the different slices, the fittest chromosomes are a bigger slice out of the bunch, while the lesser fit chromosomes are still there, but with the fittest chromosomes having a bigger slice, it has a bigger chance of getting picked. So that's one way to think about it. Next up, we have the tournament selection, which randomly chooses a few chromosomes and picks the fittest out of the ones chosen. Some cons about this is that if it randomly picks a few chromosomes, it might miss the chance on picking a more fit chromosome than the ones it chosen randomly. Next up, lastly, we have the ranking scheme, which sorts the chromosomes by most fit to least fit, and then selects from there on. So next up in the genetic cycle after the selection, we have the crossover, which is 2 of the chromosomes are deemed the parents, as said before. and they create a new offspring containing their genetic material. So a way to think about this, let's say we have two really strong parents who have really good genes, easy to gain muscle, right? And they can both create a child who can have those same traits. Like, let's say the parents are super smart or super strong and it's easy for them to gain muscle, or to run super fast, to go on long runs, and that child that they can create can have those same traits and same genetic material. And what also is super important about the crossover is that multiple offsprings can be created from the same parents. So basically, another example is that those same parents can have multiple children or multiple offsprings. So basically, we can see that, all these different offsprings that the parents created, all these different children, can all share these strong qualities. They can all take the best genes from the parents and inherit those same traits. And to connect this more with the genetic cycle specifically and crossing over in the genetic algorithm as a whole, is that these different offsprings and these different children of the parents, they provide each a solution. And basically, with producing these offsprings, the parents are ultimately, at the end of the day, just trying to find the best solution, the strongest solution, the fastest solution for the user. So after the crossover, we are now going to deal with mutation, which basically randomly changes some of the genes in the chromosomes, or new offsprings, as said before, like the offsprings presented. And those examples being changing like the binary symbols, like switching a 1 to a 0 and vice versa. And we can see a chart here that shows a bit of an example of what a mutation would look like. And it also uses this thing called a mutation rate, which is a parameter in the genetic algorithms that determines how frequent the random changes in a mutation are in a chromosome specifically. So we see below an example of what a mutation rate would look like. So we have PM equals 0.1, which basically means that 10%, there's a 10% chance of each gene in the chromosome changing. And this could be, if it was 0.3, it would be 30%, 0.5, 50%, and, vice versa. So to basically wrap up the genetic cycle, the main point is, why does this cycle and genetic algorithms as a whole perform better than various different algorithms? The reason why genetic algorithms is so much more convenient compared to the other algorithms is due to its ability to be able to speed up the process of finding the best solution possible. While other algorithms tend to focus on a single solution path, genetic algorithms gives the opportunity to not only go through multiple paths, but find the best one. And of course, this is more ideal for real-world problems by its ability to work on such complex situations and problems and finding solutions for them. So now we can talk about the applications of genetic algorithms. So in the text, they talked about engineering, for example, and in engineering, genetic algorithms have been used to optimize parameters to give overall better performance. And a specific example they used in engineering was robotics. And so basically they use general genetic algorithms in robot path planning and navigation. And another example was they talked about a 3-jointed robotic arm and how they use variable length chromosomes for them, which basically means, since with normal chromosomes they have a fixed length, while with variable length chromosomes it's where the number of genes can change. And to add on, they also use general algorithms makes a path as an ordered sequence of arm configurations for that arm. Other examples they presented for applications was planning and scheduling, where general algorithms can help find optimizational sequences that help minimize time and cost when it comes to making the best plan or schedule for its users. And more specific examples they talked about was pump scheduling for water industries, job shop scheduling, and etc. And another example of applications they talk about is pattern recognition, which basically genetic algorithms help identify within large search spaces or challenges that deal with optimization. One example they used was extraction, where the chromosomes help cipher decision making. And another one they used was recognition, which it can help optimize parameters to improve accuracy of recognition within speech and images. To conclude the presentation, overall, genetic algorithms will be seen as a revolutionary optimization technique, and most likely will be seen as one of the most powerful algorithms to be created. The text concludes by still recognizing that although genetic algorithms is a powerful algorithm, it still can face challenges approaching the real-time and adaptive capability. With that, it also highlights the positive surge of it, being integrated specifically with newer technology at the time being developed. To end the presentation, genetic algorithms' unique approach of using the concept of natural selection and applying it to craft a convenient pattern to make solution finding better and faster will forever be unmatched. Thank you for listening and watching.